Connected.
Hello. Hello students. Today we are going to discuss wave motion problems. The amplitude of a wave represented by displacement equation y equal to 1 upon under root a sin omega t plus minus 1 upon under root b cos omega t will be. The phase difference between sin omega t and cos omega t is pi by 2. So by phasor analysis we can plot the graph like this. For sin omega t this is the amplitude and for cos omega t this is the amplitude. So dear student, resultant amplitude will be 1 upon root a whole square plus 1 upon root b whole square. This is 1 upon a plus 1 upon b. So this will give us b plus a upon ab. This is resultant amplitude. So out of 4 choice, the correct answer is option 1. Option 1 is the correct answer. The relation between the particle's velocity and wave velocity is particle velocity is written as minus wave velocity into slope of the curve. This is the relation. So this is the relation. Out of 4 choice, the correct choice is option 1. Option 1 is the correct answer. In the diagram, the phase difference between points A and D is the general relation between phase difference and path difference. Delta is path difference. So this is 2 pi upon lambda into x. This is the relation. So out of 4 choice, the correct choice is option 2. The velocity of a wave propagating along a straight string is 10 meter per second and its frequency is 100 Hz. The phase difference between the particles situated at a distance of 2.5 centimeter on the string will be. Dear student, path difference is given 2.5 centimeter. Frequency is 100 and velocity equal to v equal to n into lambda. So lambda equal to 1 upon 10 meter. Now we have to determine phase difference. Phase difference equal to 2 pi upon lambda into path difference. This is 2.5 centimeter means meter. So this is 20 pi into 2.5 into 10 power minus 2. This is 50 pi into 10 power minus 2. So this is 50 pi upon 100. So this is pi by 2. So out of 4 choice, the correct choice is option 4. Option 4 is the correct answer. This is a very good question. Two sound waves are represented by the following equation: y1 equal to 10 sin 3 pi t minus 0.03x and y2 equal to 5 sin 3 pi t minus 0.03x plus root 3 cos 3 pi t minus 0.03x. Then the ratio of their amplitude. So first convert this second equation into general form. Y2 equal to 5 sin 3 pi t minus 0.03x plus root 3 cos 3 pi t minus 0.03x. Okay, this is 1 and this is. Now phase difference between sine and cos is pi by 2. Okay, so this is 5 and this is 5 root 3. So resultant amplitude will be 5 square plus 5 root 3 square under root. So this is 25 plus 75. This is equal to 10. And angle is how much? Tan theta equal to 5 root 3 upon 5. So this is root 3. So theta equal to 60 degree. So the above equation can be converted to y2 equal to 5, that is 10 sine 3 pi t minus 0.03x plus pi by 3. Now ratio of amplitude, its amplitude is 10, its amplitude is also 10. So ratio is 1:1. So out of 4 choice, the correct choice is option 1. The equation of a progressive wave moving in positive x direction is given by y equal to a sin omega t minus kx is written as y equal to a sin 2 pi upon lambda vt minus x. So out of 4 choice, the correct choice is option 3. There are 4 form, okay. Y equal to a sin omega t minus kx, y equal to a sin 2 pi t upon t minus x upon lambda, y equal to a sin omega t minus x upon v, and last one is this form, okay, in plus x direction. In the equation of motion of a particle, y equal to 0.5 sin 0.3 t plus 0.1 a sin omega t plus 5, the initial phase of motion is 0.1. So out of 4 choice, the correct choice is option 1. Equation of a progressive wave is given by y equal to 0.2 cos pi 0.04 t plus 0.02x minus pi by 6. The distance is expressed in centimeter and time in second. What will be the minimum distance between two particles having a phase difference of pi by 2? See, phi upon 2 pi upon lambda. When phase difference is given pi by 2, this is 2 pi. This is delta upon lambda. So delta equal to how much? This is lambda by 4. And what is lambda? From this equation we compare. K is given 0.02. K equal to 2 pi upon lambda. So lambda equal to 2 pi upon 0.02. So this is 200 upon 2 pi. This is 100 pi. Okay. Now we have to determine minimum distance, that is lambda by 4. Lambda equal to 100 pi upon 4. 425 pi. Oh, pi is also here. So k is not this 0.02, k is 0.02 pi. K is 0.02 pi. So pi will get cancelled here. So lambda equal to 100. So this is answer is only 25. Let's do it again. In this equation, k equal to 0.02 pi, okay, and k is what? 2 pi upon lambda. So pi will get cancelled. Lambda equal to 100. 100 centimeter. This is 1 meter, okay. So part difference delta equal to lambda by 4. This is 1 upon 4 meter. So 25 centimeter. So correct answer is option 3. Out of 4 choice, the correct answer is option 3. The correct equation of one-dimensional wave is d2y upon dt square equal to v square d2y upon dx square. Here in this equation, d2y upon dx square is what? This is curvature. And d2y upon dt square is what? This is acceleration. So out of 4 choice, the correct answer is option 1. In the given arrangement, if hanging mass will be changed by 4%, then percentage change in the wave speed in string will be. Wave speed is given by under root t upon mu, where t is the tension and mu is the mass per length. So if mass is changed by 4%, tension will also change by 4%. 4% means what? Speed will change by delta v upon v equal to how much? Half delta t upon t into 100 into 100. If it changes by 4%, it changes only by 2%. Okay. So out of 4 choice, the correct answer is option 1. Option 1 is the correct answer. If two waves are represented by y1 equal to 2 sine kx minus 300t, y2 equal to sine 4x minus 300t minus 0.2, then their superposed wave will have angular frequency. This is direct question. Two waves of same frequency and of intensity I node and 9I node produces interference. If at a certain point the resultant intensity is 7I node, then the minimum phase difference between the two sound waves will be. Dear student, the resultant equation is 7I node equal to I1 plus I2 plus 2 under root I1 I2 cos phi. This is the equation. After solving this, we will get this is 10I node plus 6I node cos phi. This is 7I node. This is 10I node. So this is minus 3I node equal to 6I node cos phi. So after solving this, we will get cos phi equal to minus 1 upon 2. So phi equal to 120 degree. So out of 4 choice, the correct answer is option 3. Option 3 is the correct answer. A tuning fork of frequency 250 Hz is vibrating at one end of a tube as shown in the figure. If maximum sound is heard at the other end, maximum sound means constructive interference will take place, then velocity of wave will be. Dear student, this is 2 meters, so the radius is 1 meter. So part difference between wave reaching at here will be how much? Pi r minus 2. This should be equal to n lambda. So this is 3.14 minus 2 equal to lambda equal to v upon n. This is 250. After solving this, we will get v equal to 250 into 1.14. So this will give us 25 into 11.4, approximately 25 into 4, 10, 25, 10, 35, 25, 28. This is 285. So correct answer is option 1. Sometimes answers remains very close. So you have to do very carefully. So out of 4 choice, the correct answer is option 1. Option 1 is the correct answer. Okay. The phase difference between the two particles situated on both the sides of a node. In case of stationary wave, phase difference between two particles located on both the sides of node is They vibrate in opposite phase, 180 degree. So out of 4 choice, the correct answer is option 3. Between any two consecutive node, particles vibrate in same phase. Adjacent to the node, particle vibrate in opposite phase. Okay. The relation between frequency n of the string, and if n1, n2, n3 are the frequencies of the segments of stress string, n proportional 1 upon L, if L equal to L1 plus L2 plus L3, so L1 proportional 1 upon N1, L2 proportional 1 upon N2, L3 proportional 1 upon N3. So resultant formula comes 1 upon N equal to 1 upon N1 plus 1 upon N2 plus 1 upon N3 in component form. Okay. So this is the correct answer. Option 3 is the correct answer. The Laplace formula for sound wave is V equal to under root gamma P upon rho. Out of 4 choice, the correct answer is option 2. The velocity of sound waves in an ideal gas at temperature T1 Kelvin and T2 Kelvin are respectively V1 and V2. The RMS velocity of gas molecules at these two temperatures are omega 1 and omega 2 respectively. Dear student, V equal to what? Under root gamma RT upon M. And V RMS is what? Under root 3 RT upon M. When you take the ratio, 3 will get cancelled. When you take the ratio, gamma will get cancelled. So directly V1 upon V2 equal to omega 1 upon omega 2. Out of 4 choice, the correct answer is option 1. Option 1 is the correct answer. Modes of vibration in a closed organ pipe are represented. In closed organ pipe, the rigid end will be node and the free end will be antinode. Okay, this is fundamental. This is first order. So out of 4 choice, the correct answer is option A. Option 1 is the correct answer. The correct graph between V square of speed of sound and absolute temperature T of the gas. V square proportional T. So graph will be straight line. Out of 4 choice, the correct answer is option 1. If length of a closed organ pipe is 1 meter and velocity of sound is 330 meter per second, then frequency is, in case of closed organ pipe, this is node, this is antinode, this is length. So lambda by 4 equal to L. So lambda equal to what? 4L. N equal to V upon 4L. So V is what? 330. This is 4 and 1. So this is how much? 330 upon 4. Now in closed organ pipe, only odd harmonics are produced. So 330 upon 4, 3 into 330 upon 4. This can be the answer. Okay, this is first order tone. So out of 4 choice, the correct choice is option 2. In case of first order tone, this will be the diagram. Okay. Two adjacent piano keys are struck simultaneously. The notes emitted by them have frequencies N1 and N2. The number of beats heard per second are N1 minus N2. This is beat frequency. Out of 4 choice, the correct choice is option 3.